everybody. Welcome to Code Astro 2025. We're so excited to have you all here. This is the 6th year of Code Astro, and it's by far our biggest year ever, so we're super happy to have you here. We hope it's going to be an awesome week. I'm going to go over some introductory welcome slides and logistics and stuff. This will probably take 30 to 45 minutes, and then we're going to get right into the first day's lesson. All right, so first I want to start with some motivation of why this workshop exists. So first of all, most astronomers have no formal education in programming, including many of us, meaning me and Jason and the TAs. This is not only bad for the field of astronomy, it causes our code to be buggy. If you've ever very common experiences for a grad student to get some code from their advisor, a former collaborator that's horribly documented and impossible to figure out how to use. It also causes us to write code that isn't reproducible, which is a really big, important thing in science. And it also causes code that's inefficient and uses up a lot of resources when it doesn't have to. It also makes us feel bad, and that's not the least important part of this. Every year when Jason and I read applications for this workshop, we get people saying things like, I want to go to this workshop because I feel like I should know how to do this by now, and I don't, and I feel like I'm a bad astronomer, I'm a bad PhD student or whatever because I don't know how to do this. So luckily, you don't need to major in computer science in order to learn to write good code, and this workshop will hopefully teach you to develop the habits of excellent software developers and give you confidence to write good open source reproducible software. So you're going to see this slide every day. These are the 3 main goals of the workshop. The first goal is to be able to use the language of software development. The second goal is to be able to develop and release an open source astronomy package from scratch. So throughout the course of this week, you're going to actually do this. By Friday, you will have released on PyPy to be pip installed your own software package and write code that follows best practices of software development. I want to briefly call out this workshop cheat sheet, which has a bunch of links that are relevant for the workshop. I'll click on it, and then I'll show you how you can get to it. So it goes to the code of conduct, the website, the GitHub. I'm going to go through all of these in the remaining slides too, but just this is one central place where you have pretty much all the links that you'll need for the workshop. The way you can get to this is either by looking at these intro slides and clicking here. You can also just Google Code Astro GitHub, the first thing that comes up, and then it's in workshop info right here. So you scroll down to the bottom, you click on it, and that'll be all that stuff here. All of the slides that we're going to go through too are also on this GitHub. So the day 1 slides, if you go to day 1, the slides that I'm looking at right now, are accessible right here. So you can follow along if you want. All right. So some logistics for the conference. All these classes are going to be hybrid over Zoom and in person. Some Zoom logistics, please mute when you're not speaking. Video is optional. All the classes are going to be recorded and distributed afterward. We're also live streaming to YouTube for the first time this year, but we recommend that you join on Zoom unless you have a reason not to. The typical schedule is going to be from 9 a.m. to 12 p.m. Central Time. We're going to do Zoom lectures and in-person lectures and interactive exercises. And then basically everything after that is unstructured time. We recommend that you use this to finish up in-class exercises. So we're going to give you some Jupyter notebooks that you can go through in class. You can use that time to finish those up. And then also to work on your group project. You'll probably, as the week goes on, spend more and more time working on your group project and less time on individual activities. There's also optional bonus lectures pretty much every day except Wednesday. There's a mix of intro, foundational level topics, and then more advanced lessons. So all of those are optional. You don't have to go to those. Remember, also, you'll have access to the recordings afterwards. So if you want to focus on just doing your project this week, and then you want to go back to the optional lectures later, you can do that. Wednesday afternoon is free, so you're welcome to self-organize social activities or take the afternoon off to rest and recover. There's also a social channel in the Discord for people that want to organize stuff. So each of you has been assigned to a group that you're going to work on your project with throughout the week. Each group also has its own assigned TA. So we expect folks participating to meet with their TA at least once per day. You can meet as often as you want, and we recommend that you stay in contact with your TA a lot. Your TAs are awesome, and they're going to be super, super helpful to you as you go through your project. The default times for TA meetings are 8 a.m. Central Time for remote people and 1 p.m. Central Time for in-person people. So if you haven't scheduled a different time with your TA, that's the time that you should assume that you're meeting with your TA. It's your responsibility, if the times don't work for you, to find a time that does work. You also have a specific group channel in Discord for your group. So you should have been added to that already. Let us know if you're not in your group's channel or if you're having trouble with any aspect of this. We recommend that you communicate with your group and your TA primarily through Discord. So we're also often going to put you into breakout rooms in person and on Zoom to work on activities in small groups. You're going to be working with your project groups throughout the week. So every time we say, okay, now it's time to go into breakout rooms, find the people that you're working on your project with and do these activities with them. So that said, if you want to change your group at any time for any reason, at any point in the week, just notify us. The option's open now and remains open throughout the workshop. You also don't need to justify why you want to change groups. You can just send me a message, I want to change to group blah, blah, blah. I want to be in group blah, blah, blah. I'm not going to ask you for clarification or to explain. So for in-person logistics, there's maps and details here. So that's in the, where is it?
Let's go to the workshop website.
Oh, okay, yeah, it's on the website. Okay. Details. Okay, so if you go to details and you scroll down, there's all this in-person stuff. Hopefully you found the room because you're here in person, but there's also suggestions on things to do, places you can get food, etc. So for folks remotely, please feel free to use this Ask for Help button on Zoom when you're in a breakout room. That'll notify the host that you want a TA to come chat with you. All right, so Discord logistics. We encourage you to change your nickname on Discord to your real name. Do that right now. This will make it a lot easier for us to find you and communicate. So if you're on your computer, you can just, I think it's right-click on your name and just click Change Nickname. You can also add your pronouns here if you want. I think Discord also has another place where you can add pronouns. Yeah, so I'm going to give you 30 seconds to do that right now. All right. I also want to point out this anonymous feedback form. You're welcome to fill out this anonymous feedback form as often as you want. You don't need to write a whole big thing every time you want to give us feedback. It could be something as simple as it was hard to see the projector today. Can you dim the lights a little bit for tomorrow? So our ideal would be that we get a continuous stream of feedback throughout the workshop so that we can adjust things in real time. You can access this, remember, if you go to the GitHub, go to day 1, go to the intro slides, you can access it through there, or it's also on this workshop cheat sheet, or you can get directly to the anonymous feedback form from here. So we encourage you to fill that out super often. We'll also have a bigger feedback form for you to fill out at the end of the workshop. All right, so the two sort of main links that will help you navigate the workshop are the website, which I've got open here, and the GitHub. So the website has a complete schedule. Sorry, this is old. We don't have office hours specifically anymore. No, it's fine. We've also got a link to the course GitHub. So all of the course materials are going to be there. So Jupyter notebooks, code, all that stuff. We've also got a README in each day's folder with project goals and lecture material. So if you want to ever check, like, what was I supposed to be doing for the project this particular day again, you can just check it there. We're also going to send around a private link afterward with recorded lectures. A little bit later after the workshop, probably like on the time scale of like months after the workshop, we'll also post the full recording on YouTube. But if you just want to like catch up on the, on the day, if you were like a little bit late or something, you can watch the private recording. All right, so project logistics. So I've told you also that the main goal of this workshop is for you to develop and release your own open source package by the end of the week. So we've got a lot more info here. This is just, if you scroll down, this is in the main README. So there's a lot more information about like timeline, time expectations here, some examples, advice, topics, all that sort of stuff. So feel free to read through that. I'm going to go over all this at a high level right now. So you're going to work with 1 to 3 others on this project. You should already be in a project group. Let us know if you're not paired in a project group or if you have any concerns about that. We encourage you to use some of the unstructured time today after the official activities to brainstorm and decide on an idea. Some ideas for things you could work on are like something related to your research. Small things work really well. So like if you want to automate a tedious task in your research, for example. You could also work on some visualization software if you made like a nice plot that you want to make accessible for other people. Or you could do some like small image processing task. Some general advice for the project. A is to limit the scope. Most of the time you're going to be spending is around the infrastructure of the project and not the project itself. So this is not really the time to spend like, developing a whole new thing for your research. You're mostly going to be writing docs, tests, making your code open source, etc. It's totally okay for the main code to be pretty short. We also encourage you to check in with your group's TA at least once per day, and ideally to stay in much more constant contact with them. Also, it doesn't need to be perfect. Make sure you're keeping focused on the project goals every day. We've also got the suggested timeline if you scroll down here, and we're going to tell you specifically what project goals are for each individual day at the beginning of the day. Okay, on the very last day, on Friday, we're going to do project presentations. So this is really fun. The first 60 minutes, you can optionally present to the whole conference. So you can sign up to do that at this spreadsheet right here. We're also going to remind you on Thursday, so you don't have to like sign up right now. Just know that that's there for you. And the next 30 minutes after you do the whole project presentations, you're going to swap projects with another group. And this is super fun and super chaotic. The group is going to like pip install your package and try to run through some tutorials of your package. So you're going to get like hands-on experience interacting with your users and seeing how they use your package in real time. Spoiler alert, it's not going to work. It's going to be super crazy, but you're going to learn a lot and it's really fun. So general advice about how to group work. I am a person that always hated group work, and I felt like I either had to do everything myself or I was like totally uninvolved. So the goal is to structure group work as much as possible so that you don't feel the way that I always felt during group work. We're going to use this paradigm called pair programming. So one person is the driver, who's actually the person that's typing code on their computer. Another person is the navigator, who watches what gets typed and offers directions. So they might say like, oh, that actually, you missed a parentheses here, or like thinking more sort of big picture. So this is like a big picture person and a small picture person. So the driver thinks more about the right syntax, the navigator thinks more big picture about how the code should work or function. The key is that you switch back and forth so that one person isn't always doing one thing or the other. So I encourage you to, especially the first day, literally like set a timer of like, okay, we have 20 minutes for this activity. There's 2 people in my group. I want to spend the first 10 minutes being the driver, and then you'll spend the next 10 minutes being the driver. You can get a little more like, free-flowing with it after the first day, but I do encourage you to be pretty strict about it on the first day. In 3-person groups, 2 people are the navigators, and then you similarly rotate that around. We also, if you're on Zoom, encourage you to use Discord or Zoom to share screens. You should be able to do it directly in Discord, but I think a lot of people are more familiar with Zoom, so that's fine too. Yeah, for today and tomorrow, we suggest you do as much pair programming as possible when starting off designing your package. Later in the week, especially when you hopefully get more familiar with GitHub, you'll be working more, you can work more independently and do things like one person does this and then you come back after a few hours and integrate everything. But today and tomorrow especially, do a lot of pair programming. We're going to talk about Git branches today, but we encourage you to code individually when they're separate tasks. But yeah, again, later in the week. So we also encourage you to assign roles for each participant in breakout rooms. So these are the driver, navigator. For some tasks, we'll have other particular types of roles. So we'll tell you about that. But yeah, we encourage you to actually assign those roles and rotate them as necessary. Another really key thing is that especially when you're working in a group, it can feel really at least I feel like my brain sort of shuts off when I'm in a group situation and I'm oh, I have to solve a problem right now. So we encourage you to take the first 10 to 15 minutes, 10 to 15% of the time that you have in your breakout room to just think individually and understand the problem, start making a plan to go through it, and then come together and actually start coding as a group. We'll try to remember to remind you to do this, but also just do it. All right, so probably the most important slide, how to ask questions. So we've got lots of different ways for you to ask questions during the workshop, and that's to try to make it as easy as possible for you to ask questions and to see other people's questions. You can ask questions in the chat box over Zoom. We prefer that you don't unmute during class, so if you have a question, you can either let us know in the chat or use the raise hand feature. I really encourage you to use Piazza. Piazza is this platform that hopefully you all got an invitation to or signed on to as part of your onboarding for the workshop. Piazza is really nice because it's easily searchable, and there's also an anonymous option for asking questions. So if you don't want us to know who's asking the question, or if you don't want other people in the class to know who's asking the question, for whatever reason, you can ask that question on Piazza. I'm going to encourage you at the end of today to actually ask a question on Piazza. So I'm going to sort of force everybody to ask a question so that you get some experience using Piazza. And then also you can ask questions on Discord. I really prefer that you ask questions on Piazza because we can search them and assign them to TAs. But you can also ask questions on Discord. We recommend mostly that you communicate with fellow participants on Discord. So think of Discord like the way to chat with people and coordinate stuff, and Piazza as a way to ask questions to the whole workshop and to us. And we're also going to be monitoring these mediums before, during, and after the lectures. So if you, for example, ask a question on Piazza, as I'm talking, I'm not going to answer it, but a TA will look at it and answer it in real time. So you can totally raise your hand and ask a question during the lecture, but you can also use Piazza. So we've designed this course to take about 35 to 40 hours of your time in total. This includes 15 to 20 hours on lessons or synchronous activities, 5 hours on individual work outside of the synchronous activities. This might be finishing the activities that you started in class or going over answer keys. Then 10 hours on the group project. So this is about 3.3 hours per day, Monday, Tuesday, and Thursday. And then 5 hours lunch, breaks, rest, chilling out. However, we totally understand that people have different amounts of time that they can give to the workshop, especially people remotely. So please discuss time expectations with your project group members. And also remember that you're going to have the materials from this workshop forever as references. So you don't need to understand everything 100% this week. Focus on getting as much as you can out of it, but don't worry about getting everything. Okay, so I also want to take a second to acknowledge everybody who's in the room, potentially the Zoom room. So there's people here that could teach this class. There's people here that have no experience with anything that we're going over this week. There's people in between these experience levels. There's people of different genders, ethnicities, races, and sexualities. There's people from different socioeconomic classes. There's people from different nations, a lot of different nations. That's one of the things I really love about Code Astro is that it's really international. People with disabilities, and people who are stressed about something other than the workshop. You're all welcome here, and you all belong. And also, everyone has different goals and priorities for the workshop, and people are going to get different things out of the workshop depending on what they're bringing to the room. That's okay. So I hope you all feel welcome. With that in mind, I want to introduce our code of conduct. I'm going to read through this first part of it, and then just let this second part let you read through it on your own. No, wait, sorry, I got it backwards. I'm going to read through the second part, and this first part I'm going to leave you to read on your own. So we encourage everybody to adhere to these following principles: to treat others with respect, to recognize the humanity of people with different backgrounds, life experiences, and preparation levels, acknowledge your own contributions, and agree to share your work, recognize and celebrate the contributions of others, create a culture of giving and receiving constructive feedback, committing to a mission of supporting equity, diversity, and inclusion in science, and being conscious of your contributions to group conversations. Talkative folks like me should be careful not to talk over others, and we also ask you not to use curse words or make potentially offensive jokes. And with that, thank you so much for helping to make this a welcoming and friendly environment for everyone. And again, there's this anonymous feedback form, so if you're concerned about anything, or if you're feeling uncomfortable at any point in the week, we encourage you to fill it out. We're also going to enact these following social rules. So these 4 social rules, you can read through this a little bit on your own later, but I'm just going to briefly talk about them. There are no well actuallys, no feigned surprise, no backseat driving, and no subtle isms. So here's some examples. So no well actuallys. Alice says, I just installed Linux on my computer, and Bob says it's actually called GNU Linux. So no well actuallys. No feigning surprise. Example is, what's the command line? And the other person says, wait, you never use the command line? So no feigning surprise. No backseat driving. Bob says, what's the name of the string copy function? Alice says, string copy. And then Eve says, you should actually use strl copy, it's safer. I don't actually know how to pronounce any of these. And no subtle ism. So don't make analogies to, don't subtly incorporate like sexism, for example. So someone says Windows is hard to use. Bob says, no way, Windows is so easy to use that even my mom can use it. All right, so now we're briefly going to introduce you to your instructors and TAs. So my name, I guess I should have introduced myself, sorry. My name is Sarah Blunt. My pronouns are she, her, hers, and I'm a postdoc at UC Santa Cruz. I'm interested in exoplanets and statistics. We're gonna why don't all the in-person TAs come up here, and you can come get in line and you can introduce yourself when it's your time. And the remote folks can unmute when it's time.
You can keep yours on. Let's
Okay.
use the second one.
Cool. Yeah, you can come.
Okay, so I'll go next.
Hi, I'm Jason Wong. I'm a professor here in Northwestern, and my pronouns are he, him, and yes, good to see everyone, and hope everyone has a great week.
All right, shall we?
Yes. All right, Ray. Ray is sadly sick, so she will be around later in the week. So I should also say that Ray and Kruthi, who you'll hear from in a second, are the head TAs this year, so they're also really good people to ask questions if you have them. But yeah, so Ray just graduated from grad school at UC Irvine and is about to start her postdoc at NASA Goddard. She's interested in exoplanets, stellar rotation, and mission service, and works on the Pandora and Roman space telescopes. She does creative writing, science fiction, dance, D&D, and nerd stuff. Ray also has read like an unhinged number of books. She read like 40 books in a year or something like that. Probably that's an underestimate. And Ray attended in 2022 and has TA'd ever since, and has TA'd both remotely and in person. All right, Kruthi, feel free to unmute.
Yeah. Hi, everyone. I'm Kruthi. My pronouns are she, her. I'm a PhD student at Daisy in Germany. I live in Berlin. And my research interests are gravitational wave follow-up, like especially binary neutron star mergers. And CodeAstro, I've been here since the beginning, 2020 participant, yay. And yeah, I've TA'd before multiple times, once in person and twice remote. And this year, yeah, I'm a head remote TA. So if you have any feedback or anything related to your remote experience that you immediately want to be changed, or say some of your group mates didn't show up, so you can just like let me know and we'll see what can be done. And for fun, yeah, I mean, I've listed a bunch of things. Bottom line, I do everything and anything, and you'll just see me fiddling with a lot of things. And you can reach me on email and Discord. I would prefer Discord though, and here's my handle. Yeah, so nice to meeting all of you. Excited to work with you.
Thanks, Kruti. All right, Sama.
Hello, everyone. My name is Sameh. I'm doing my PhD at the University of Cologne in Germany, and I'm studying something called active matter, where we're like a group of fish or a group of people or sheep, and we study the dynamics of them. I done been in Code Astro the first year, then I've been teaching since the first time, except one time. And for fun, I'm playing chess and traveling and reading a lot of manga and manhwa. You can reach me on Discord at this username. If you have any problem with Discord, or you are in the wrong group, or you need to be moved between groups, or something is not working, the voice, screen sharing, just let me know.
Thanks. All right, Hania.
Hello everyone, I'm Hania, pronouns are she, her. I'm a PhD student at Ohio State University, and right now I'm mostly doing exoplanets, and I focus on planet formation simulations, mostly the late stage and the rocky ones. And my background was actually in something completely non-astro. I did mechanical engineering for my undergrad, and then I decided that it's okay, but not for me, and I switched to astronomy in grad school, and it's been really nice. And I did Code Astro last year, and I loved it, and I'm here again, I guess. And the stuff that I like to do for fun, I usually just like outdoor stuff. I really like climbing and backpacking and running and stuff. And also I really like trying out new coffee shops. For an example, I've tried 3 since I arrived yesterday. And I'm really excited to get to know all of you and work with you, and I hope we have fun. I really had fun last year, so I hope you all have fun this year. Thanks.
Hi everyone, my name is Sheila Sager. I'm a grad student at the University of Florida. I work primarily on exoplanet demographics in the galactic context. I did my undergrad at Boston University. Now I'm a PhD student at UF, I already said that. And this is my first time as a TA for Code Astro after participating in 2022. And I'm so excited to get to know all of you and see all of the ideas, like the cool ideas you come up with your projects. For fun, I like makeup, fashion, like skincare, hair stuff, all that stuff. I love watching beauty YouTube, trying new restaurants, and traveling. So I have a picture of me in the ramen noodle aisle, which is like my favorite place ever. Yeah, but I'm really excited to get to know all of you. Thanks.
Chai.
Hello, I'm Chaitanya, or you can call me Chai. I'm currently a research engineer at the Cosmostat lab in CEA Paris-Saclay. I did my master's in astrophysics from India. Then I worked for a couple of years as a software developer in India, and now I'm here as a research engineer. I was a participant in Code Astro in 2023, which was super fun. So I'm back here again, this time around as a TA. I'm super excited to meet you all, and I really like anything computational, free and open source software. I really love puzzle hunts, and I like my music and I like to sleep. Thank you.
Maria? Maria,
Can you hear me?
Yep.
Okay. So, woohoo! Remote TA here from Finland, from Helsinki, also where the Santa Claus lives most of the year. So I have two kids because it's evening right now and there's some background noise. I'm sorry about that. But I finished my PhD at the University of Turku, which is in Finland, and I studied observing of galaxies around active galactic nuclei, basically merger candidates in terms of their observational properties through spectroscopy and photometry, which was a lot of fun because I got to observe in several observatories, including in Chile. So now I'm starting soon a postdoc in this EAPS, which is part of the Italian Astronomy National Institute in the location of Rome. So we're in a process of moving, and I will be working on the moon survey, which is advanced spectrograph to look at distant galaxies around redshift 2. So my background is very crazy. I don't have a linear background and I have a lot of gaps in between. I worked sometimes 4 jobs just to make ends meet and pay for my education. I also did a lot of study abroad, including 1 year in Paris when I took my first physics classes in French, and they were the quantum mechanics, the graduate level ones. So I studied as a biology, got involved in astrobiology, which led me to do astronomy later on. And I'm also finished education in humanities, including a master's degree in French. So I can very relate, and I want to encourage everybody, if you don't have some sort of traditional background and you need somebody who is down to earth to talk to you about it without judging, I'm that gal. And everything else about the workshop, I'm a remote TA. So all questions welcome on any channel, Piazza or Discord, or just ping me to set up a Zoom meeting or anything. I'm here to help you. Have a great time. Thank you.
Thanks. Elizabeth?
Hi, my name is Elizabeth. I'm a postdoc currently at the University of Tsinghua in China. I'm interested in globular clusters. I love these kind of objects, and I study them using simulations, mostly embodied simulations, but as well cosmological ones. I did my PhD in the Institute of Astronomy in the UNAM in Mexico. And last year I participated in this workshop and I also loved it. I learned a lot and I wanted to give something back, so this year I am a TA. And for fun, I enjoy playing video games. I don't play as much as I used to, that's sad. Also, I love making 3D animations and plots, also hiking and exploring cafes around the world. So we should talk about this later. Welcome here.
Vidya? Oh, Vidya is not on right now, but Vidya's so we've got 2 remote hubs this year for the first time, one at University of Maryland, and one at UC Irvine. This is also the best picture I've ever seen of a person ever. Vidya's interested in climate dynamics of rocky planets, orbits of cold Jupiters. She was a participant in 2024 and is a first-time TA this year. Also, fun fact, Vidya started working on a research project with me after Code Astro last year and is going to submit a paper this week. And for fun, she likes swing and salsa dancing, hiking, traveling to national parks and new countries, and she loves corgis.
I promise I made a slide. You just might have to refresh.
Let me do that.
That's my bad. Hi, everybody. I'm Elle. And I'm the remote TA at the UMD hub. I promised. I'm a PhD candidate at UMD College Park, where I'm hosting the remote liaison hub here. I do direct imaging of young giant exoplanets, try to constrain how their atmospheres evolve over time. I attended Code Astro in 2023, and it is the single thing that made me not be afraid of Git anymore, and it fully changed my life. And since then, I've been ranting to everybody how they have to do this. I'm really excited to be able to help facilitate that for you guys. yeah, outside of that, I host a monthly craft night at my house. If any of you guys are in DC on the full moon, let me know. I do a lot of camping, playing music, big into tree identification. That's my deal.
Awesome, thanks. Okay, thanks everyone. Yay. All right, so now we're going to do a quick breakout session. The main point of this is for you to find your group mates if you're in person, and if you're on remote, to figure out how to use the Zoom breakout rooms. So spend likely most of the 5 minutes doing that, but if you have any time left over, introduce yourself, name, career level, research area, and then talk about A, how do you feel about coding, and B, what are your goals for the workshop? All right, so I'll call everybody back in 5 minutes. All right, everybody. So before we take a quick break, I just want to tell you about the overall goals for the workshop for today. So the main goals for the lessons for today are that by the end of today, you're going to be able to identify which development environment is most appropriate for your programming task, design when and how to design software using functional and object-oriented paradigms, use Git to contribute version-controlled code, and define Git flow and give examples of the advantages of using Git flow. The project goal for your project today, we want you to decide on the purpose of the package and to write one central function or class and put it on GitHub. So an example, if we're working on a package that plots the most likely galactic orbits for a user-specified subset of the Gaia catalog, today, me and partner 1 will write a function that uses galpy to compute and plot orbits for a list of stars, and partners 2 and 3 will write a class for constructing the list of stars using user input. We'll use 2 separate Git branches to do this, and we'll talk about Git branches too later, so don't worry if you're not familiar. Before we get started, I also wanted to tell you 2 ways of saving your changes to the Code Astro repo. So you can imagine that we don't want every single person pushing all of their changes to the one central repo. So you can do one of 2 things. Option 1 is you can save changes only on your computer, so they won't be available, they won't be in the cloud, they won't be available online for you or other people to use. So the way you do this, you should have already Git cloned the Code Astro repo as part of the setup instructions. So you change directory to wherever you put Code Astro. Then you type git stash, which is basically storing the changes that you've made on your computer. Then git pull, which is going to take any changes that I made at 5 a.m. this morning when I was preparing down to your local version. And then git stash pop, which is going to reapply your changes. So basically holding your changes, pulling in the new changes, and then reapplying those changes. So this is, remember, this is the way that will only make your changes accessible on your computer. And of course, if you run into issues, please feel free to ask a TA or one of us. Option 2 is making your changes on GitHub, putting your changes on GitHub. So this is called creating a fork of the repository. So you have already cloned the repository, so there's 2 steps to this. The first step is to make a fork. So this is sort of your own copy of the Code Astro repository that you can make changes to. So if you go to the Code Astro GitHub page, there's this little button at the top here that says fork. So you just press it. There's 1 or 2 screens that it'll take you through to set up your fork. And then step 2 is to set up the Code Astro repository on your computer to track the changes from this fork. So the same first step, you go into the Code Astro repository. Then we're going to add an upstream. So this is basically telling your local fork to pull any new changes from my version of Code Astro rather than your forked version of Code Astro. And then the next thing is git remote add origin to your username's Code Astro. So that's saying if I want to push my changes, if I want to put my changes on GitHub, here's the location where I'm going to put them. Don't worry too much about this. If you don't understand, you can basically just use these commands. Remember, these are 2 options. You don't have to do both. You can do one or the other. And all of these commands are in the day 1 intro slides, so you can go back to them later. All right, so we're going to take a 5-minute break, and then I'll hand it over to Jason for your first official Code Astro lesson.
Yes.
So let's come back at 9:57.
Yeah, 57 minutes after the hour.
57 minutes after the hour.
Okay, hi everyone. Let's get back started. So let's let me share my screen. Share screen. Okay. So we're going to start off today talking about development environments, or where do we write code? So an application that allows us to help us write code. We're going to briefly talk about kind of 3 different classes of development environments. The first class are these things called IDEs, or integrated development environments. IDEs, or integrated development environments, are kind of your a one-stop shop for like all of your software development needs. These things usually have a lot of features. Sometimes it gets a little confusing and maybe it's a bit harder to learn. But we think it's worth the small effort to learn to use one because it helps you in your development in the long term. So the kind of the 2 leading IDEs for Python are VS Code and PyCharm. In this workshop, we'll be teaching you how to use VS Code and demoing features of it throughout the week. It's something where, you know, the first time you use one, you're like, there's a bajillion buttons. I don't know what I want, where anything is. I just want to type like my code. How do I even open a file? And that is totally a natural response. But hopefully we think that once you work on it a little bit, you get used to it, you'll find that it actually helps you rather than makes things more confusing. So if you've never seen VS Code before, Sarah has a video from the day 0 installation instructions for kind of introduction to the VS Code workspace. But I'll just briefly highlight a couple features. So this is VS Code. VS Code has like a bunch of things all going on. The first aspect is that it has a file explorer on the left-hand side. So like I've opened up an entire folder in VS Code. I've opened up my Code Astro folder so I can see everything that's in the Code Astro folder. If I open up a Python file, let's just make a new Python file. Test.py. There's already something called test.py. Okay, test2.py. Good. On over here, there's this is your window where you can actually type things. You can do like import numpy as np. And you know, this is your regular text editor screen. At the bottom here, this is your terminal. So if you ever use terminal for like running programs, running scripts, that's part of your development environment. It's all kind of together in this in the same windows. You don't have to switch between various applications. One of the nice things about something like an IDE is that if you install the Python integrations that come along with it, for example, in VS Code, you have to go to your extension side to install the Python extensions. But once you do install them, they come with helpful things. One of the things is like autocomplete. So if you're typing something, you forget what the function you want is, you know, you can type something halfway, and I'll give you an option for like, here are all the functions in NumPy that start with ARRA that you could possibly use, but this is jot your memory on which one you want to use. And even you're like, okay, I want to use NumPy to array, but how do I call this function? You can hover over it, and it will give you the doc string of the functions. It just tells you basically how this function should be called. This one is a little bit clunkier than the other ones, but it also basically, if you go to the NumPy webpage, right, on your browser, you can look up, you know, NumPy array. It'll give you a whole page for here's how to call that function. Here's the arguments. Here's the returns. Here are examples. You can also, in VS Code, just hover over that same function, and it'll give you everything in the contents of that web page. It tells you the parameters that you can pass in. It tells you the return type. It tells you other functions that are similar to this one. It gives you the examples. They are the same ones that are on the web page online. You can just basically see them as part of the doc string here. You can basically do this all without having to leave the application. Sometimes it just saves you a few clicks to having to context switch between switch between different different applications and things like that. So here you're like, oh, okay, I just want to make an array. Let's like 1, 2, 3. These things also come with things like what's called static linting, or it's basically like a spell checker for your code. So if you do something like if you type something that doesn't exist, it'll give you the little squiggly just like it does in a word processor. Oh, let me make this bigger. Just like in a word processor, and you'll see there's a little squiggle here, and basically tells you, hey, there's something wrong with this code right here, and you can hover over it and it'll tell you, oh, this variable name is undefined. You've made a typo here. This is not the type thing you want. So instead of having to run your code and waiting for it to crash and then go back to debugging, as you're programming, it flags these errors for you. Okay. Debug mode, and right. We'll talk more about debugging later in day 2, but there's some very nice features over here on the left. There's a search bar. There's this debug mode that we'll talk about tomorrow, about how do we use VS Code to debug our code. Is one of the things I think is the most underappreciated parts of how to use an IDE is using its debug mode feature, because its debug mode feature, if you know how to use it well, can save you lots of headaches. It can save you hundreds of lines of print statements to basically help you figure out the bug without having to write all those print statements. It also has a Git integration, so you can you can use Git through this VS Code interface rather than do it from the command line. I think we'll demo a little bit of both in this workshop. So it depends on if you prefer this, or you can just do things from the command line. Both work, but this is another way where they try to make things a little bit user friendly. Okay. Yes, and then there's some other useful features of VS Code that we aren't going to talk about, but I think are useful to point out. In astronomy, oftentimes we have to SSH into a remote machine, a computer that's not our own laptop or desktop. And sometimes it's very clunky because you're in that little terminal. You're like, I can't do very much. I can't open up Windows. I can't open up applications. You can actually use SSH on your local laptop to SSH into a machine, and you can basically open up a folder on the remote machine just like as if it was a folder on your local machine on your laptop. And basically this has replaced my having to need to use like Vim or Emacs or anything to edit something on a remote server. I can edit it all on VS Code on my laptop with all those helpful features you just saw there. For Windows users, there's a Windows, you should have already set up your Windows subsystem for Linux installation. And then there's also this extension marketplace that can be used to customize VS Code with a bajillion plugins. You can basically tune it to exactly however you'd like. Okay, the next thing we're going to talk about just briefly is Jupyter Notebooks. Jupyter Notebooks are like what you see here. This is a Jupyter Notebook. Jupyter Notebooks are useful because it's a combination of code and text cells. So this is just a text cell. It's just a cell with some syntax formatting to make it look a bit nicer. You can also make specific code cells, so you can import NumPy as NP and run it. And this is going to tell me that this is not authorized by Google. Okay. So you can run code, you can and alongside the code you can also have text. So it's a nice little notebook that allows you to kind of document your code as you're writing it. It's also nice because you can control which cells get run in which order. So it's good for running or rerunning code cells at a time. It lets you play around with the code, lets you try to understand the code, lets you kind of develop it kind of iteratively and see your code evolve basically. It's useful, especially for plotting, useful kind of for solving a problem. You can think of it like this is a document. This is like instead of like if I'm turning in a homework question problem, this is like my document that documents the entire homework problem. It's really nice in a lot of different ways. There are some things to note of when you are using Jupyter Notebooks. The output of any given Jupyter Notebook cell depends on the order in which all the previous cells have been run. So basically, if I if I have some code blocks, one is I said a equals to 1, and then this one I said a plus equal to 1, and then I have another one that asks me to print a, right? So if I run this cell 5 times, the output of this cell depends on how many times I've run this cell. And this could be good as we're iteratively playing through the code and trying to understand how code works, but it's not very good for repeatability or reproducibility. Like you don't want to have to come back to this piece of notebook and remember that you need to run this middle cell 5 times in order for this code to output what you think it outputs, right? That's not something that we like to do for long-term sustainability. And it's also not really designed to program a software package where you have many different files all interacting with one another. This is really good for kind of solving one particular problem or documenting one particular thing. So we'll be using Jupyter Notebooks throughout the workshop to kind of showcase things and like use it for activities, but it's not what we're recommending you to use when you're actually writing your project in the afternoons. And then lastly, we'll mention about plain text editors. Plain text editors are kind of these are your quote unquote old school tech coding environments like Vim, Emacs, Nano, Notepad. We're going to generally recommending that you avoid using these to program your code too much. They are more likely. I'm not saying they're prone to bugs. Maybe we should reward that. It's easier to write buggy code with them. Basically, we think there are better tools out there, and this is what we're trying to make you learn in this workshop: is to learn how to use IDEs if you haven't used them before. Sometimes inevitably in astronomy, you end up having to use one of these text editors. So it's good to know how to open up a file window, how to edit the file in one of these editors, and how to, most importantly, save and close that file in one of these text editors. But generally, I've maybe used Vim, I think, once in the last 2 years. This is because VS Code has basically taken over anything I need to edit on a terminal. So I basically haven't really used one of these plain text editors in a long time. And I just want to, because this workshop did not meet this 6 years ago, we need to talk briefly about generative AI tools. Both VS Code and Colab come with AI tools for writing code. We're not saying whether you should or shouldn't use this code for your normal software development needs. We're just asking for the purposes of this workshop to turn them off because our answer keys are floating around on the internet. So there's a good chance they know how to do all the activities we are doing in this workshop. So because of that, for the purposes of you learning, we're asking you to turn them off just so that you don't start working on one of these notebooks and suddenly Google Colab just tells you the whole answer. And you're like, what am I even thinking, right? So how do you do this? In Google Colab, AI autocomplete is on by default. To turn it off, you go to the top right here onto the settings gear. If you click on that and you go to AI assistance and you want to uncheck this first box, show AI powered inline completion. So if you turn that off, then in Colab, then these AI autocomplete features get turned off. And then if you want to turn them back on, just go turn them back on. Just for the purposes of the activities in this workshop, we found that they start completing too much of the activities if you have it on. In VS Code, by default, I believe AI integration is turned off. But if you do have it on, if you go to the bottom right corner here, there's this little icon. This is the Copilot icon. And if you just uncheck Python, then it will stop giving you AI autocomplete suggestions in Python. But if you haven't turned it on, you don't need to do anything because it's off by default. You have to turn it on. Okay, we'll talk briefly about AI tools on day 4, but generally I think the AI tool landscape is evolving so fast that we don't really have a full lesson on how to use them or where you should be using them, but we'll talk a little bit about the ethics of using AI tools at the very end. But we're not saying you shouldn't use them. We're just saying that you don't use them for the activities because they will solve them for you. Okay, all right. So let's go on to that's kind of development environments. So we'll be mainly talking about how to use IDEs kind of throughout the workshop. But for the purposes of this first section on programming paradigms, we're going to do it all in Jupyter Notebook. All right. So we're going to talk about object-oriented versus functional programming. So first, let's talk about object-oriented programming. This workshop was created in 2020. So these memes are now what we call, I think, are a little rustic. Yes. that we can call them vintage. They're vintage memes. Let's take a second to appreciate the meme. Yeah. All right. So object-oriented programming, you might have heard of it. You might have been like, oh, maybe I should be using this. So what is it, and should you be using it? So object-oriented programming is kind of built around this idea of classes, that classes are kind of the central thing that all your code is structured around. So a class in Python can contain many things. It can be used to organize variables into it's basically used to organize variables and functions into a single object. So a single container that has a bunch of variables and functionality. For example, we can make a class called the telescope class. The telescope class can have functions like telescope.close_shutter, and it can have attributes like telescope.current_target. And anytime we move to a different target, this field telescope.current_target gets updated to the different next target that we're pointing our telescope at. When we're done using the telescope, we can run this command telescope.close_shutter to close the shutter of the telescope. Objects are useful because they can be used to track the state of things, which is very useful for modeling many things in the real world. Many things in the real world change. They have some properties that we want to track, and objects are a way for us to kind of containerize those properties and know where to track those properties. So the example of the current target telescope that turn target variable that tells us, when we slew to a new target, when we point our telescope at something new, we update that field, that variable with the new target that we're pointed at. Classes also have something called inheritance, and this allows classes to kind of have a hierarchy. Classes can take fields. Classes take fields and functions from a superclass or parent class. This is really useful for reorganizing or reusing code. For example, in our telescope kind of example, in addition to a telescope class, we can also have a child class or a subclass called space telescope. Space telescope would basically inherit all the properties of the parent or superclass, such as telescope.close_shutter and telescope.current_target. So as the space telescope points to a different target, the telescope.current_target field also updates. But each subclass, such as a space telescope, can have specific functionality that doesn't apply to the superclass or parent class. For example, a space telescope may have the field distance to Earth. Distance to Earth is not relevant for all telescopes. So majority of telescopes are on Earth. The distance to Earth is 0. So that field is irrelevant. But for this purpose, the space telescopes is something we want to actually track. So the distance to Earth might be a variable or field that's specific to the subclass space telescope that doesn't exist in the superclass or parent class telescope. And this is different from the current target field, which exists for both classes. And then the diagnostic notebook, which you all did in registering for this workshop, has some basics on class and superset class syntax. So I think the best way for us to really actually get a handle on object-oriented programming is just to try some. And we've we built this activity called to basically build a mini gravity simulator, and we've already structured the code in an object-oriented way, and you just kind of have to fill in some code to basically finish off this gravity simulator in an object-oriented way to kind of give you a sense for, here's how an object-oriented program is structured. We basically finish up programming this free fall gravity simulator and use your simulation to determine how long it takes for a particle to fall to the ground from a height of 10 meters. Obviously, you guys probably know how to solve this analytically with pen and paper. We're not doing that. We're doing it numerically on a computer just to calculate how long it takes for a ball to fall from a height of 10 meters. We'll poll everyone at the end. I'll tell you how to post your results in a second. And then if you finish all that, there's a bonus activity to basically, we also have a superclass, this particle superclass, and basically think about what aspects of the free fall particle subclass, which I'll show in a second, should belong in the superclass. Okay, so I'm gonna go over the code briefly and then tell you a little bit about what to do. So we have this particle superclass. For the first part of the assignment, the main part of the assignment, you don't need to look at this at all. This is just structure. But if you finish the main part of the assignment and want to work on it, the bonus part of the activity asks you to basically populate this particle superclass with things that you think should belong here. For the purposes of this activity, we're going to work on this class called freefall particle. This freefall particle class is a simulator that simulates a particle falling due to Earth's gravity. The particle is stationary at first. So every class that you create usually comes with a init function. It's always written like this: underscore underscore init underscore underscore. And this is the initialization function of the class. Anytime you create a new freefall particle object, it will run this initialization function. And this initialization function, the first variable is always self. This is because the input self is required for all functions that belong specifically to an instance of an object. If you want that function to recognize the dynamic changing state of that object, then you need the first variable argument of the function to always be self. And then the second the second variable could be any optional variables any other required variables that you believe need to be passed in. Here is the height. So this is the height that the particle is starting from in meters. So how far from the ground is this particle starting from? And this is what the initialization function looks like. You just run super.init. This initializes this parent class. Right now, the parent class is empty. It does absolutely nothing. So this function does absolutely nothing, but it's there in case we want to initialize it. And then here, we can basically set the attributes of this particle based on the initialization. So we've set the height. We require the user to pass in a height. So we set the height of the freefall particle to be the height that we pass in. This is the current height of the freefall particle in meters. We're passing it in from a height of 10 meters, or passing in from this height that the user initialized it. So we started off at the height passed it. At time equals 0, we're starting out the time as time equals 0. At time equals 0, as the freefall particle is at rest, it just started there, so the velocity is also 0. Self.dt, this is the time step in the simulation. So for every time step in the simulation, how much time should have elapsed? By default, you see that dt is 0.1 seconds. So every time we run the simulation, we want to move forward in time by 0.1 seconds. And then the self.g is just the gravitational acceleration. Don't change this. Earth's gravity is constant for the purposes of the simulation, always negative 9.8 meters per second squared. So after you define this function, what happens is that if I call ball equals freefall particle 10, then calling this function, creating this object, calls that init function we just looked at. Creating this freefall particle object runs this function and returns an object where the height is 10, the velocity is 0, the time is 0, dt is by default 0.1, and self.g is still negative 9.8. And this is all encapsulated into this new object we just created. This object can have other helper functions, such as this one's called get num steps run. This is the function that returns the number of time steps that have run in the simulation. So if the time step is 0.1 seconds and the time elapsed is 1 second, then we know that we know exactly 10 time steps have been run in the simulation. So this is a helper function. But again, this helper function starts out with self. Every function that belongs to an object starts off with self. For the purpose of this activity, what you'll do is to basically code up this function called simulate time step. Simulate time step advance the simulation time by a single time step, self.dt, and updates the simulation with the new time, height, and velocity. So your goal is to basically add functionality to this function to advance the particle's height and velocity one time step at a time. There's some useful pseudocode here to remind you how to update a new velocity and a new height for moving forward and by a small time step. So you can use this code to help you. And we want you to return the height of the ball in the current height of the ball in meters at the end of this time step. So how this is going to look is that I'm going to create a freefall particle class starting at a height of 10 meters, and this is going to return it into this object called ball. If I print ball.time and ball.height, I expect the time to be 0 and the height to be 10 meters. If I run simulate time step, I expect that time should move forward by 0.1 seconds, and the height should decrease a little bit because the ball is starting to drop. And if I call simulate time step yet again a second time, time should move forward by another 0.1 seconds to 0.2 seconds, and the height should also drop again by a little bit more. And you'll need to change this code so that you run it until the ball eventually falls to the ground. Right now, this function, oops, I forgot to call this function after I create this. This function right now does nothing. You'll see that every time we print it, time has not elapsed, the ball still has a height of 10 meters. So it's your job to implement this. This is just to kind of get your feet wet and in the workshop, and also kind of give you a sense for how to program in object-oriented style. Your end product is that we have a new Piazza post. You can reply anonymously is fine with your result that you computed computationally on how long it takes for a particle to fall to the ground from a height of 10 meters. Like Sarah mentioned, we're going to do this pair programming kind of fashion. This is something that's used actually in software engineering companies. When someone's kind of especially new to programming at the company, they do this pair programming kind of style. One person should be the navigator. One person should be the driver who's in charge of typing the code on the screen. And then the other people are the navigators who should be in charge of thinking and actually telling the driver what to type. So your instructions is to figure out who is in what row based on the criteria above. The person that lives at the highest latitude should be the driver, and everyone else should be the navigators. So read through the current code that I just showed you and discuss as a team, or think a little bit, maybe spend 30 seconds to a minute thinking by yourself, and then discuss as a team on what needs to be done to complete the main goal. We provided you some hints. Code it up and get an answer. And if you have time, discuss with the team how you can accomplish the bonus activity as well. Yes, so we're going to give everyone about 25 minutes. So we'll return at 50 minutes after the hour. So people in person break up into various pods here in the lecture hall. On Zoom, we'll do the breakout rooms and go into the breakout room that corresponds to your group. And if you have trouble finding your group, please let us know. So let's come back in 25 minutes or 50 minutes after the hour. Okay. All right, let's get back together. Looks like a lot of you guys successfully figured it out. So how long it takes for a ball to drop from a height of 10 meters? We got a lot of 1.43 seconds, 1.4, 1.428571400000003986. There's some floating point precision bound errors there. 1.43, 1.43, 1.4. Looks like people did a good job. So if I also have what we thought were our answer key solutions. This is not the answer, but it is a answer. So here, the only things we modified are in the simulate time step code. So just following the pseudocode, we've updated the velocity with the new velocity at the next time step. We update the height based on the new velocity at the next time step, and then we update the time to increment by the next time step. And then we just put this in a while loop. So basically we made a ball that's a free fall particle of a height of 10 meters. And then while the height of the ball is greater than 0, we keep running simulate time step until the ball eventually drops. You can see, and we print out the time and the ball height each time. And as it drops, we get 1.4 seconds. Seems like everyone did a good job there. I'm not gonna talk about the answers to the bonus activity because there's kind of a bajillion answers. This is kind of how you want to structure your code, what variables should belong in which parts. But hopefully that got you a bit thinking about, how can I make these classes and super subclasses and have this kind of hierarchical structure that maybe allows my code to be more reusable and more flexible, and what should belong where to maintain usability, but also kind of decrease the total lines of code that possibly could be used. The other thing I want to mention here is the answer key is pretty short, right? We added 3 lines of code to basically solve the problem. And this is not because this was meant to be a super easy exercise. It's just, this is kind of representative of how oftentimes software development happens. Is that, which is why we also try to push you to first think about it and then talk with your group members on how to solve the problem. A lot of software engineering is conceptualizing the problem and determining how you want to solve the problem, not actually the physical lines of code written. So sometimes something that requires a much
fewer lines of code may have required a lot more time conceptualizing, but in the end is a more efficient solution. So, I think here's one example of the case where we expected you all to take some time to think about the code, kind of understand the structure, and then just because it was 3 lines at the end, it doesn't mean this was an easy activity. It was just like the activity is mainly about you kind of conceptualizing this kind of framework, this object-oriented framework, more than knowing how to write simulation code, which is not the purpose of this workshop. Cool. So that's object-oriented programming. We're going to talk briefly about functional programming. A few things on object-oriented programming. Object-oriented programming, as you just experienced, is really structured around objects. Objects are kind of the key cornerstone of the design of the code. Object-oriented programming in particular depends on the changing, or as we call in programming, mutable state of objects. We utilize the fact that this height variable and the time variable is changing over time. And that was the foundation of how we built our simulator, was that this height and time variable would change and we would update it as we ran the simulation. Many things in the world change, so it makes a lot of sense oftentimes to program things in this object-oriented fashion. And we recommend that when you first start creating a package or start thinking about writing some sort of software tool, envisioning what kind of entities should become objects and program around this. For example, particles in a simulation you can be grouped together in a class. If you're writing a data reduction software, maybe all the data reduction software is using a certain kind of file structure or a data structure. That data structure maybe is a spectrum, could be grouped in, it could be a class where we expect all the spectra that you process through this data reduction pipeline all has a particular structure that allows you to kind of standardize how you process that data. There are some subtle things to consider, but when using classes aren't free. Creating an object does take time and is slow. Relatively, for the purpose of making a single object, this is talking about like a fraction of a millisecond, so we don't notice it at all. But if you're starting to make 1 million to 100 million objects, you'll start noticing this in your performance. So too many object creations can actually slow down your code. And another thing to actually be careful about is that object-oriented programming can be more prone to bugs, because the outputs of a function depends on both your inputs and the state of the object itself. Oftentimes when you write a function, you just think about, I call a function simulate time step, and you don't think about all the implicit state of this ball object that went into producing that output. And it's much harder to kind of reason through that. And because of that, sometimes object-oriented programming, when you program things in an object-oriented style, your functions or your code may produce things that you didn't expect. And this is because it depends on the implicit state of the objects at runtime. So this is something to be careful of when you're programming in an object-oriented fashion, is that all of these functions depend on the implicit state of this self variable. Okay, if you are interested to learn more about object-oriented programming, we linked a few blogs about first a more conceptual discussion of how to use object-oriented programming, how to design object-oriented programming, and then a more technical discussion of here are all the features in Python that you can use to enact object-oriented programming. All right. Now let's move to functional programming. So let's take look at our vintage meme for functional programming. Very good. I still see that the vintage memes are still getting appreciated by the youth. Good. This meme is actually outdated. I feel like functional programming is seeing a resurgence in software development. You're seeing a lot more frameworks and languages actually being programmed in a functional way. So what is functional programming? The key paradigm, unlike object-oriented programming, is that function outputs in functional programming depend solely on the inputs. It does not depend on the mutable changing state of objects. This is nice in one way. It's easier to guarantee correctness, where every time I call a function with these inputs, it will always produce the same output. It makes things more messy to track the changing state of things, and we'll show an example of that in just a second. Functional programming doesn't mean that we're not using any objects at all. However, objects are static data structures. And This functional programming is often useful for math problems, physics equations, unit conversions. AstroPi units is actually a great example of functional programming. If you ask AstroPi units to convert meters to nanometers, we're using objects here, but we're actually doing this in a completely functional way. This line of code will always produce the same answer, 10 to the minus 9. Here's an example of the free fall simulator written in functional programming. It's a bit clunky in some ways, as you'll see. We have this particle object, but this particle object now has almost nothing in it. It's just a class with a height and a velocity. That's all that this object has. It has nothing else except for height and a velocity. And we have now this new free fall time step that given a ball, given a particle or a thing, and a time step, how much you want to advance the time step, we simulate the free fall particle for one time step. And the main difference is that all the things are the same, except that instead of returning the same thing and modifying the thing's height and velocity and time, we create a new particle at that new height. So basically, the thing that gets passed in and the thing that gets returned out are two different things. And this allows us to get this is because we're purposely not changing the state of any objects. Every object, once created, remains static forever. So to create a new instance of the particle at the next time step, we got to create a new particle altogether. And so in this case, basically every time we run free fall time step, we get a new instance of the particle that's falling at a different height. And then we pass in that next particle into the next time step to basically simulate it. This is where functional programming differs in the intention of object-oriented programming. If I call free fall time step with the same ball object, and I get a new output ball, these two output balls in functional programming are always going to be the same. They're going to always look the same. Whereas in object-oriented programming, these are often not guaranteed to give you the same answer because it depends on the implicit state of that object that's changing over time. Here, we know that this object ball that we input in never changes. So every time we call this function, we will always get the same answer. So you can see how this both can be clunky sometimes, but also can be nice other times for guaranteeing repeatability. So this is just want to end with this object-oriented versus functional programming kind of trade-offs. Object-oriented programming is good when things change. Functional programming is good for deterministic things. And there's a lot of times in astronomy when we want deterministic things. Math equations, if we want data reduction pipelines to produce the same answer every time, making sure we don't apply the same function twice to some routine that we really don't want that to happen. Most modern packages oftentimes use both, whether they think about it or not. And it's not like one is superior than the other. These are different design paradigms with kind of different trade-offs and different kind of advantages in different use cases. So oftentimes these are just tools to solve an engineering problem, and like any group will have a different approach to doing so. So this is not like you should always be using one or you should be always be using the other. Think about what is your application. Do you really want to track the changing state of things a lot? Or do you want to really make sure that every time I call a function, this is always going to return to me the same output no matter what happens? So these trade-offs are kind of engineering design choices that you'll make, and something you can think about as you design your packages this week. So that's everything for this. That's everything for this. We'll take a 10-minute break. Is that so good? So we'll return at 12 minutes after the hour to talk about an introduction to Git. So let's take a quick 10-minute break, and then we'll resume.
All right, everyone, let's get back started. So before we start, we can take a moment to appreciate the meme. We're going to use Git for version control. That means it'll be clear and easy to use, right? Right? All right, so the plan for this next 45 minutes or so is that we're going to go through 1.5 lessons about Git. The first is an introduction to Git. The second is about Git flow. We're going to do the activities for the Git flow lesson tomorrow, but the Git lesson activity we'll do right now. All right, so why would we use Git or source control in general? So the definition of source control is any system for tracking changes in files. So if you've ever like saved one version of something as version 1, and then another version as version 2, and then another version as version 2 final, and then another version as version 2 final, you're also using source control. Git is a way of doing this in a more streamlined and automatic way. So why might we want to do this in general? One nice reason is that you have organized like legacy versions of your code, so you can easily make different versions of the code available and make it easier for users to like go back to a particular version. You can revert easily. Another really nice application is if you suddenly break your code and like, okay, I know it was working yesterday, I don't know what changed, you can easily revert to that or even see the differences between that version and this version in Git really easily. And it's also really nice for collaborative work. So as we'll talk about in Git Flow, you can often, this is an organized way of having multiple people or editing the same code at the same time. So our recommendation is to use source control and GitHub in particular anytime you're programming, even if it's just for yourself. So when I'm working on my research, even if I don't expect anyone else to directly contribute to this code, I very, very often use Git and GitHub to organize my thoughts, and also to transfer my work between different computers that I might be working on. All right, so the bulk of this lesson is we're going to do a demo showing you an introduction to Git. In the demo, you're going to learn to make a Git repository in GitHub and copy it to your local machine. We're then going to add and edit files in the repository. We're going to resolve conflicts between the remote version and the local version of your files. And then I'm not going to go over this, but in the activity, you can remove changes you don't want to keep. So in the past, we've tried to do a type along, and it always goes really poorly, so we're not going to do that this year. So I encourage you, don't try to reproduce what I'm doing as I'm doing it, just pay attention, and I'll point you to where this like demo lives so you can actually go through it. Just to give you a preview, the group activity is just going to be to like reproduce everything that I just did as a group. All right, so let's do it. Pull up my list of things to do. All right, so we're going to go to GitHub. So here's my GitHub profile. I'm now going to create a new repository in GitHub. So this is just my profile, my landing page. I go to repositories, then I type new. We're going to name the repository. What do you think we should name the repository? Any suggestions? What? Test 3. Love it. The third test. Okay, here's also where you can choose the visibility. So you can make your code public or you can make it private. So if you want, so often if I'm like working with like proprietary data, I often still use GitHub. I just make it private. You can also have an option, let me make this slightly bigger. You have an option to add a README here as well. So let's toggle that on so we can see what it does by default. You also have this option to add this gitignore file. Gitignore is this thing that tells Git not to track particular files. So for example, if you have a file like, DS store is a common one on Macs, which just like stores the organization you like your icons are on your desktop. You might not want to like put that on GitHub. So this gitignore file, if you add a default one, Python, it has a whole long list of files that are like not generally tracked by GitHub. You can also add a license. We're going to talk a little bit more about licenses when we do the releasing code lesson. I'm just going to add no license for now. All right, I'm going to create my repository. All right, now I've got my nice new repository. You can see it automatically created this README with the name and the description of the repository. The next thing I'm going to do is clone the repository to my local machine. So right now, this repository only exists in GitHub, so it only exists in the cloud. So GitHub is a place where repositories are stored. Git is a tool to like interact with things like Git and GitHub, like GitHub. Got a little recursive there. So let's clone this repository. We click the clone button. I'm going to click this to copy the URL to my keyboard. Then I'm going to open this up in a terminal. Another thing I should have told you at the beginning is initially I'm going to do all of this not in VS Code. So you're going to see like actually how this Git stuff works from the command line. And at the end, I'll do it in VS Code and hopefully convince you that it's so much easier to do it in VS Code, and you should always do it that way. All right, so first I'm going to go to where I keep GitHub repositories on my computer, which is Documents GitHub. And then I'm just going to type git clone, and then I'll paste the URL of the repository I just made. So now if I ls, you can see this test3 is right here. So I'm going to change directory into that test3. The first thing I'm going to do is git status. This is sort of like the ls of Git. It tells you like what's going on if you have changes that like haven't been, that aren't being tracked or are being tracked. So right now there's a couple things it says. First it says that I'm on branch main. We're going to talk about branches later. Your branch is up to date with origin main. That means that there's no changes between my local copy, the version of the Git repository that's on my computer, and the remote repository, the version of the repository that's on GitHub. It also says nothing to commit working tree clean. That means there's nothing in my local thing. The next thing I'm going to do is I'm going to create a new file. So I'm going to use Vim to do this. So Jason said he hasn't used Vim in like 2 years, so we're about to use Vim right now. Let's create something called hello.txt. So I'm creating this new file. I'll say like, hi there. Now I'm going to, this is how you save and exit in Vim, very important, :WQ. Now if I do git status, you can see it says untracked files, hello.txt is here. So this means right now that Git doesn't know about this file. It doesn't know, it's not like, it's not keeping track of this file to like update the local versus remote versions. So the way that we tell Git, this is something I want to track, this is something I want to make sure can be updated back and forth between the remote and local repositories, you do git add, so you do git add hello.txt. Now if we do git status, you can see it's green and it says changes to be committed, this new file. So this git add just says like keep track of this file to Git. The next thing we're going to do is git commit, which actually like creates a unit of code that can then be passed back and forth between the remote and local repositories. So we're going to git commit, and then you can add a git commit message. So you do -m and then what we want to say. So let's say added a hello.txt file. Fun fact is that we used to have a TA, Simon, who said that one time he was in a software engineering interview and his interviewer actually like looked through his git commit messages and was like, oh, why did you like write that there? So the point of that story was, other than just that it's funny, is that having like informative commit messages is actually really helpful, especially if you're trying to figure out like what happened, when did I introduce this thing that then broke the code. You can go back and rather than looking at like long strings of commit identification numbers, you can actually look at like a human readable thing of like, here's what I added when. So don't discount git commit messages, they're very helpful. All right. So now if we do git status after we committed, you can see your branch is ahead of origin main by 1 commit. So we have something that we've committed locally. The remote repository, GitHub, doesn't know about it yet. So if we go to GitHub and we refresh, it doesn't know anything. It doesn't, well, it doesn't know anything. It doesn't know about this hello.txt yet. So the way that we keep the remote, that we inform the remote about the changes that we made locally is with this git push command. So we'll do git push. So now it gave us some output, and then if we go back here and we refresh, you can see that hello.txt is now there. So we've now, everything is up to date. All right, one other thing I want to show you is the git diff command. So I'm now going to edit hello.txt again. So let's open up hello.txt. We're going to say something else. What else do I say? What should we add to the file? Doesn't have to be clever. I can't come up with anything clever right now. Huh? Test 3, yeah. No, it's got to be test 4 now, right? Okay. So if we do git diff hello.txt, you can see it's got this, oh, no, sorry. I need to commit it first. So let's git add hello.txt, and then git commit -m added test 4. So now if we do git diff, just kidding. Okay. Okay. Why did it not? Never mind. Okay.
You have the test 4 right.
Oh, yeah. I didn't see it. Thank you. The perils of live demos.
Yes.
Okay. Yeah, so here it showed us that there was a difference between the local version and the remote version. So it says, okay, this line was added. So this is the difference between the remote version and the local. Okay, so now I've committed this, so I can push it back to the remote. All right, so now if we refresh this again, you can see that our changes have now been pushed. Okay, the next thing I want to do is tell you about git pull. So push and pull can sort of be confusing with git sometimes. Push is taking changes from somewhere and putting them somewhere else. So if I'm git pushing from my local repository, I'm taking the changes that I made on my computer and I'm pushing them to GitHub so that they're available in the cloud. Git pull is the opposite. It's taking changes that were made somewhere else and pulling them into your local version. So if I, from my local repository, say git pull, it's going to check the remote repository for any changes, and then it's going to pull them in. So you can see right now it says already up to date because there's no difference between the remote repository and the local repository. Now let's try making a change. So now I'm going to manufacture a conflict. So the idea of this is when like 2 people are editing the code at the same time and Git doesn't know how to resolve this. So let's first simulate this by making an edit on the local version. So I'm going to now, let's say, I'll remove test 4. And then I'm going to git add hello.txt, and then I'll git commit -m remove test 4. So I've committed it, so my local repository, like this has been like etched in the local version of Git that like this is a change that has been made. I'm going to now edit it on the remote repository, so in GitHub. So let's say we made a different change. Say we, instead of deleting it, we just changed it to be test 5 instead of test 4. So I'm going to commit the changes directly from GitHub. Here's where my commit message goes if I'm committing directly on GitHub. Test 4 to test 5. Okay. So now, if I just did this locally and I wasn't aware of all those changes that were going on in the remote repository, the next thing I might try to do is git push. So we get this error. It says failed to push. Updates were rejected because the remote contains work that you don't have locally. So Git is saying there's stuff that happened in GitHub that you don't know about here. So we need to make sure that we're aware of that and we need to resolve these changes. So the first thing we do is git pull. We're going to grab those changes from the remote and make sure I have them on my local repository. So I'll do git pull. So it gives us this message, conflict. There's a merge conflict in hello.txt. Automatic merge failed. It wants us to fix the conflicts and then commit the result. Note that this doesn't always happen. Git has some logic to automatically resolve conflicts. The most common case of this is, say, like I was editing one file and you were editing a different file. If you git pull, it'll automatically like just pull the changes that that other person made. But we do now, it's saying, okay, so one person deleted test 4 and one person changed it from test 4 to test 5. Git is saying, I don't know how to deal with this. You as the developer need to figure out how to fix this. So what happens when this happens is that when I open up hello.txt, you can see there's this weird stuff here now. So there's this head, and this thing is the local commit message. So basically what it's saying is that head has made this change of like deleting the text, deleting the line of code, and head meaning the where I currently am locally. And then the remote repository has changed it from test 4 to test 5. So Git is saying, I don't know which one of these to do. I need you to figure out how to help. I need you to help me figure out how to resolve this. So you can just treat this like a text file and just edit it to be the way that you want it to be, and then commit the result. So let's just say we want to keep test 5 instead of test 4. I literally just delete these lines of code. Then I'm going to save, and then I'm going to git commit. Now let's do git status first. Okay, so we'll git add hello.txt, and then I'll do git commit -m fixed merge conflict. Okay, so now if we git push, we go back here and refresh, we've got the resolved merge conflict. All right, so the last thing I want to do is show you how to do all of this in VS Code. Yeah, question?
What happens if you had kept the deletion? Was it okay?
Sorry, I didn't hear.
If you kept the deleting the test code, would it have pushed okay still?
Yep. Yeah, so basically you can, oh yeah, so the question was if you had kept the deletion, would it have pushed okay? So you can do pretty much whatever you want to that file as long as you git add and commit it, then it'll push that result. So you're just telling it, Git is telling you here's the difference. You could even just git commit with all that arrows in it and the code wouldn't run, but like Git would be like, okay, yeah, you've figured out that that's the result. Yeah, great question.
So like on the user side, it feels like I just want to make an edit and then do git push. That would be like the easiest thing. But you have to do git add and then git commit. So add is like, from our perspective as a user, something fancy's going on under the hood, but it doesn't really matter, right? You just kind of like have to do it.
Yeah.
Important about it.
Yeah. So the question is, what does git add actually do? So a counterexample might be helpful to understand why you might need git add. So say you have a lot of files in one repository, but you only care about passing some of them back and forth between GitHub. Like say you have huge data files or something in your local repository. A really common example for me is like MCMC chain. So something that's like a huge HDF5 file that I don't want to pass back and forth between the remote and the local. So I wouldn't git add those big files that I only want to keep locally. I would git add the stuff that I actually want to like track in code in Git. So git add communicates to Git, the piece of software, what you want to track.
Oh, so if there's changes made to those files, but you didn't have them, it won't flag it.
Exactly. Yeah. So if you make changes to a file, but you don't git add it, it won't communicate those changes to the GitHub repository.
Same question for commit. Is that just so you can add like a message that's document stuff?
Yeah, exactly. You can think of, so Jason's going to talk a little bit more about what commits actually are tomorrow, but you can think about it like a series of signposts. So if you're looking back in your code, it's sort of intermediate between I'm creating a whole new version of the code and every single time I type a new character, I want to save the change. So it's sort of like saying, okay, here's a milestone that I reached in the code that I want to easily go back to. Best practice is to commit early and often. So we generally don't recommend waiting until you've made a huge amount of change to commit. But do small commits and do it often and have descriptive commit messages so that you can go back to that point in the code often or easily. Yep, another question.
You basically just answered it, but my question was going to be what if you have a large folder with lots of things in it and because git commit and git add are often and do it for little changes, but if you have multiple files
Yeah, so I think the question was about like if you make lots of changes at once, like how do you decide what to git commit? Yeah, generally I recommend doing it like in as small units as you possibly can. So if you can commit like, each file individually, that's probably good practice. In reality, like often I'll commit several files, changes to several files at the same time. But yeah, generally like committing changes to like 20 files at once is probably not great practice because you likely made lots and lots of changes. So a good thing to think about is like you want your commit to have something that you can describe succinctly in a commit message. So if you start like making bullet points to describe everything you did in that commit, it's probably too big of a commit and it's worth breaking it up into smaller commits. Yeah, good question. Yeah, honey.
On adding the files and then the example that you mentioned on having large data files, I don't know if it's best practice or not, but sometimes if I have a folder that just has lots of data, I just add it to that ignore file, so it already knows that just don't add this stuff. Is that something?
Yeah, exactly. So that's actually what git ignore is like doing, is just basically saying like, I'm gonna default not git add these things. I'm gonna ignore these things. So they're not gonna be tracked by git. Yeah, so Hania's point, sorry, for the people online was if you've got like a bunch of big files, you would just add those directories to the git ignore file so that it will communicate to git. I don't care about tracking these files.
Accidentally once I just did git add dot and it added everything and it was trying to upload gigabytes of data into GitHub and it took me some time to unload.
Yeah, totally. Just to repeat for the people online, it was, she was saying that one time she did git add dot, which adds everything in the local repository. And if you just commit and upload all of that, it could upload like gigabytes of data without you realizing. Other questions? Mm-hmm.
It's also sort of telling Git what you're actually going to push to the repo. So if you maybe not that perfect and made 25 changes, but you don't want to stick them all in one commit, you could, in theory, like commit some changes and then commit some other changes and then commit some other changes.
Yeah, totally. So this is called chaining commits. So you could do exactly that. You could make lots of changes, do one commit without pushing, make changes, do another commit, and then have like a series of commits. Then you can then upload to GitHub with one command, one git push command. Yep.
Sorry, this was very
No, yeah.
The issue of big commits data, because I know GitHub is not really for data storage. If and when this sort of thing is needed, is there something that's recommended right now when you want to have sort of group accessible data and you don't want to Google Drive or Dropbox, because that's really what they're for?
Yeah, good question. So the question was like, if you do have big data that you want to like share with people, how do you recommend doing it? You can do it with Dropbox and Google Drive. Those are totally fine options. There's also a specific thing called Git LFS, Git Large File Storage, which like specifically does this thing of like tracking large data files. But often Git like by itself will actually like fail to upload really big files. It'll like time out. So if you want to track big files on Git, I would recommend using Git LFS. Yeah. Other questions?
Hi, Sarah. I have a question.
Uh-huh.
Can you hear me?
Yep.
Yeah, just I'm asking what if I put some code in my locally machine and my counterpart made changes in the GitHub page, but we want to keep both the code in the merge system. How to do that?
Yeah, so you can basically the same way that I just showed you, you just rather than like, deleting all of the code except the thing you want to change, you want to keep, you would just delete the like carets that say like this was from one branch, this was from another branch. So maybe the easiest way is to show an example. So let's say I'm gonna add like, here's a new line. Oops. I'm gonna git add, and I'll git commit, added something. Okay, then remotely, I'm also, did that turn off?
Turn out battery.
Oh, okay.
This one.
Thanks. Sorry, technical difficulties. Okay, so now let's say I want to add something else. I can commit the changes, say like add something else. All right, so now we'll first git pull. So it's, that actually did it automatically. So it realized that we weren't editing the same thing, and it just pulled in both. So now if we look at hello.txt, so now you can see that both of them are automatically there. So yeah, it will try to do this automatically. If it can't figure out how to do it, it will ask you to manually figure out what to do. Let's go on because I want to show you how to do this in VS Code, and then I'll take a couple more questions at the end, and I'll let you practice with this as well. Okay, so the first thing I want to do is open this repository in VS Code. So remember, I cloned this already to my local machine, so I have test3 on my computer. I can just open it the same way I would open like a Word document. So just go to File, Open, and then I go to where I keep these things on my computer, repositories, was it? Test3. Okay, and then I'll open it. All right, so you can see in the File Explorer, I've got git ignore, I've got my README, and I've got hello.txt. All right, so first, the first thing it's going to tell me to do is sync changes because I've got local commits. But let's say I want to make a change. So let's say, hi there, everyone. So I save it. And then you can see this is the source control tab. So this is like VS Code's GitHub integration. So you can see that it automatically shows up as like, I made changes to this. So this is sort of like a git status. It's saying what changes have been made, what's the difference between these and on the local and the remote. So to git add, I just do this plus here. You can do it on an individual file basis if you only want to add individual files, or you can just do this, which will add everything that you made changes to. So let's do that. So now it says that hello.txt is in the stage changes. So that's like after we've done git add. We can then commit. We write our commit message here. So let's say added everyone. Then I commit. And then you can see there's sync changes 3. 3 means that we've made 3 commits. You can do that here. You can also do it down here. There's another little git integration here. So we just push that. So that's the equivalent of the git push command. And then you can see back on the repository, we've got, hi there, everyone. You can also see that the commit message shows up here in GitHub. So the most recent commit message is actually written next to each file. Yeah, that's pretty much all I wanted to show you. Yeah, okay. So now I want you to get some practice. Don't worry about messing things up. I think messing things up is how you figure out how to use Git and GitHub. But yeah, the group activity is to reproduce the steps of the demo. If you have extra time afterward, choose a group member and have everyone clone the demo repo have one group member create a repository on GitHub, have everybody clone that repository, and then try to edit the same file and both push. See if you can resolve merge conflicts. But the first order thing to do is just reproduce the steps of the demo. So just to remind you where the demo is, if you go to, let's just get to it from Google. So if you do code Astro GitHub, it's the first thing that comes up. Then if you go to day 1 here, if you go to git intro and git demo, this is the demo. So this is all the steps that I just went through here. So just one more time, just Google code Astro GitHub, go to day 1, go to git intro, git demo, and then follow those steps. So I'm gonna give you 10 minutes. Don't worry if you don't finish, just try to sort of get as far as you can in that time. And then we're going to very briefly go over Git flow, and then we'll do the Git flow activity tomorrow. All right, so I'll give you until 53 after. All right, let's wrap up. Again, no worries if you didn't finish. Basically, the main point of today's afternoon session is to give you time to catch up on everything that happened this morning. So make sure that you know how to log into Discord and Piazza, finish the activities, connect with your group mates, sort of figure out all the logistics of the workshop, and catch up on all the stuff from this morning. I just want to point out that at the end of this presentation, there's a list of Git commands. A lot of these can be automatically done with VS Code, but these are just enumerating all the things you can do from the command line. I also just want to give a couple of suggestions about practices to avoid merge conflicts. So now you know how to resolve merge conflicts if they come up. But that being said, nobody actually wants to resolve merge conflicts. It's really, frustrating and tedious and annoying to go through and tell Git okay, accept this change, don't accept this change. So some helpful practices first is to always git pull from origin, from GitHub before working on code. So that's making sure you have all of the changes that have been made to the remote version on your local machine before you actually start making changes. Another good suggestion is to git commit and git push changes early and often. The smaller units these changes are, the easier they are to work with. One really common thing that I see, especially with junior developers, is that people will wait to commit their code until they feel like it's totally done. And then by the time they're actually ready to commit the code, the base of the code has moved really far ahead. And so it actually takes a lot more work to merge the branches together and make sure that everything is up to date. So don't worry about it being perfect. Merge, commit, and merge early and often using merge. We haven't really talked about merge yet. Also, if applicable, you can also use non-Git things. So coordinate with collaborators on which sections you want people to work on. So it's totally fine to split up the code and make it modular so that certain people work on certain things and other people work on other things. All right, so we decided that we're going to do Git flow tomorrow. So we're just going to do a little bit of wrap up, and that'll be day one. So I'm going to pass it over to Jason.
Okay, good. All right, we made it through day one of the synchronous activities for Code Astro. Hopefully that wasn't too bad. I just want to point you at one of the resources. We've started to use jargon, if you notice, specific programming jargon, some of which we tried to define, some of which we may have forgotten to define. We have a crowdsourced vocab list of kind of software jargon available at this Google Doc. This Google Doc is on the closing slides, which you can find by going to GitHub, and I'm not going to do the live demo right now. You can go to the GitHub and go to the day one folder, and the README on the day one folder, there should be a link to the closing slides. Okay, just remind you all how to ask questions. Please ask questions often. Folks have been doing a pretty good job already. You can ask it in the chat box on Zoom while the synchronous sections are happening. You can ask them on Piazza. You can ask them on Discord. In fact, we're going to try to encourage people to ask things on Piazza, and that we're going to go probably a few minutes over at the top of the hour. We're going to spend 5 minutes now for everyone to log into Piazza and ask a question. It could be any question you have, other than something on today's lesson. Could be something that on the setup. Could be something on how you're what to do for your group project. Could be something unrelated to any of that. But everyone go onto Piazza and ask a question. This will keep the TAs busy for the afternoon to answering all your questions. Let's spend 5 minutes doing that right now. Okay, yes. Okay, so hopefully everyone had a chance to ask a question. Just remind people on our goals for today. By the end of today, you'll be able to identify which programming development environments is most appropriate for your programming task, decide on when and how to use functional and object-oriented programming paradigms, using Git to contribute version controlled code, and you'll learn about Git flow tomorrow morning. And then just a reminder, your project goal for today is to decide on the purpose of your package, to write one central function or class of that package. And as a pro tip, when choosing a name for your package, check if it already exists on pypi.org, pypi.org. That way you don't conflict with any existing Python packages that are already out there. Picking a unique name is good to help with that. Today's optional lessons, we have 3 is the most of any day. We kind of split them up into 2 different categories. There are foundational lessons and advanced lessons. Foundational lessons are kind of like core concepts in Python programming that if you feel like you really haven't had a good exposure to, this is a good lesson for you to kind of get more of exposure into those foundational aspects. Advanced lessons are kind of techniques in Python that majority of people probably will never have to use, but maybe it's something of particular interest to you or something you've always wanted to learn, or something that you think is relevant to your work. But probably for the majority of people, you probably don't ever need it. So we have 2 foundational lessons, NumPy Pandas from 2 to 3 p.m. Central Time, Matplotlib from 3 to 4 p.m. Central Time. And then we'll have JAX as our first advanced lesson from 4 to 5 p.m. Central Time. This will all be on the same Zoom link as we are here this morning. All right, just a few more slides. Just remind you all, no apologizing for anything in this workshop. You know, this workshop is for you. The resources and materials are made to, however is best for you. So, if there's times you need to step away, times where you don't think you can participate as much, that's totally okay. We're not evaluating you. This is not a class. Although you're in a lecture room and it feels like a class, this is not a class. Use this workshop for how you want to learn. And don't sell yourself short. We've gone through a lot already. We've kind of put you on a whirlwind of a morning. So you all belong here. We accepted you for a reason, and you can do this. So keep at it, especially. It seems like everyone's doing great, and just don't sell yourself short. Just to remind folks, we have an anonymous feedback form. Please the link to that is in various places, including the closing slides here. So you can, we'll remind you about it once per day, but please fill it out if you have any feedback you want to give. Keep an eye out for recordings of the workshop from today and answer keys for the activities we just did. And have a great rest of the day and night from everyone. And thanks for everyone for connecting on Zoom and bearing with us. And I think that's the end. All right, so we'll break there, and that's the end of the synchronous sessions for today. We'll stay on Discord and Piazza and things like that, but we can break here. Thanks, everyone.